Okay, welcome to our introduction to parametric equations. And we're just going to work through this together. Feel free to pause it if you want to do some work ahead of me. So let's say you're lying in bed and there's a spider that is 7 feet above you and 10 feet to your right. Is this a reason to be concerned? Well, maybe. How fast does it move, right? And I guess how scared you are of spiders too. So we have two equations, and these are functions. So we're going to say x is a function of time and y is a function of time. And they're going to represent the horizontal and vertical position of the spider in terms of time. We are laying still in bed, just watching. So this first equation, x is a function of t, which is time, is described here. The y is described here. Let's fill in our little table here. So if time is 0, the x value is going to be 10 minus 2 times 0, or 10. If time is 1, 1 times negative 2 is negative 2, plus 10 is 8. 10 minus 2 times 2 is 4. We'll just subtract that, we get 6. And then for time being 3, 3 times 2 is 6. 10 minus 6 gives us 4. So those are the x values here. And now we're going to do the same thing using our y equation. So when y will be determined by 7 minus 1/2 times t. So when time is 0, 7 minus 1/2 times 0 is 0, so that's just 7. When time is 1, I put a 1 in here, so 7 minus 1/2 is 6.5. When time is 2, 2 times 1/2 is 1, 7 minus 1 is 6. And finally, when time is 3 seconds, 7 minus 1/2 times 3 is 1 1/2. 7 minus that gives me 5.5. Now, if I want to look at the coordinate points that come from this, here's my x value, here's my y. So the coordinate point is 10, 7. Again, that represents where the spider is. It is 10 feet to my right and 7 feet above me. At 1 second, it's at 8, 6.5. At 2 seconds, it's at 6, 6. And at 3 seconds, it is at 4, 5.5. Okay, so now it says let's go ahead and plot these points on our graph. So let's go ahead and do that. Sorry, let me zoom in a little closer so you can see these. First point is at 10, 7. There we go. Next one is at 8, 6.5. And I'm kind of estimating here 6, 6. That one's a bit easier. And then 4, 5.5 right there. And it says connect the points, draw arrows to indicate the direction of the spider's path. Well, there is my little line. And the spider started here at 10, 7. As time progressed, it was moving this direction. So I'm going to put an arrow there. So that is the direction the spider is moving. Next question, what does the origin represent on the graph? Well, I care about where the spider is relative to me. So the origin represents my location. So that is where I am. I'm on the bed. Will the spider ever reach you? How do you know? I'm not sure. Let's take a look at the graph. If we were to continue on the same path, let's assume the spider does he come to the origin? If I were to just take a quick look here, it doesn't look like he ever gets to the origin. He's going to go past me. So no, spider's path never crosses 0, 0. Because again, that's where I'm located. So it doesn't look like the spider will get to me. It doesn't cross the origin. How many seconds have passed by the time the spider is 3 feet away from me horizontally? Okay, we're going to have to set up some equations for this. And the equations were given to us in the beginning. So my location in terms of x, the horizontal, is given by this equation. My vertical distance is given by this equation. So if I want to know when is the spider 3 feet away from me horizontally, I'm going to use this equation. What I'm looking for, let's just write it again. So x is a function of t, and we know that we want to be 3 feet away from us. So when that equals 3, 10 minus 2 times 3. Oops, we don't know what the time is, do we? So let's leave that as t. And we want to solve for this. So I'm going to subtract 10 from both sides. I get negative 7 equals negative 2t. Divide by negative 2, and I get t equals 3.5 seconds. So at 3.5 seconds, the spider is 3 feet away from me horizontally. How far above me is the spider at this point? Well, so I've got to use this time, but in my vertical equation. And the vertical equation is that y is a function of time, 7 minus 1/2 t. I don't know what this value is, so I'm going to put in my 3.5 in for t, because I know I want to see it at a time of 3.5 seconds where it is. So 7 minus 1/2 times 3.5 gives me 5.25 feet. So spider is 5.25 feet above me, and it is 3 feet to my right. And those things occur at a time of 3.5 seconds. And if we want to write an equation for the spider's vertical distance from me when he is x feet away from me horizontally. So I want to take time out of the equation. So I've got to solve the first equation for t. So I'm going to solve equation for t. So it doesn't matter if I solve the vertical or the horizontal equation. Generally, we will do the vertical one, the one with x, the horizontal. And then we're going to substitute that into the vertical equation, the equation with y. So solve equation for t and then substitute. So my first equation is that x equals 10 minus 2t. Well, I'm going to solve this for t. So I'm going to subtract 10. So x minus 10 equals negative 2t. And if I want t, I've got to divide both sides by negative 2. So t is equal to x minus 10 divided by negative 2. I'm now going to take this value for t, so t equals x minus 10 divided by negative 2, and substitute that into my y equation. So my y equation is y equals 7 minus 1/2 times t. So I'm putting this in there, x minus 10 divided by negative 2. And that is now my equation for y in terms of x. And I could certainly simplify that, but I just want you to see how we get it. Is we solved one equation, typically the x equation, for t. Once I've isolated t, I then substitute that into the y equation. Okay, so if my arm is 2 feet long, could I reach the spider when he is directly above me? How do I know? Well, it's going to be directly above me when x is 0. So when x equals 0, I'm going to put it into this equation to see how far it is vertically from me. So y equals 7 minus 1/2 times 0 minus 10 divided by negative 2. And if we plug this in, we have negative 10 divided by negative 2, that's a 5, multiplied by negative 1/2 is 5/2. Subtract from there, we get 4.5 feet. So no, I can't reach the spider. So hopefully I can relax now. And know this, as long as the spider continues on its own path, I will be fine and not have to interact with it. Okay, let's turn over and get some key ideas here. Okay, and I've got these written out for us already, so you might want to pause it, but the key concepts or key ideas with parametric equations is that a parameter is the third variable, and usually it's t for time, used to generate values for both x and y. Parametric equations can be used to describe curves that are not functions, or where order matters, and we indicate that by the arrows, or where the domain is restricted. Converting from parametric to Cartesian, we solve for t in one of the equations and substitute this expression for a t into the other equation. And so again, generally we start off with a function for x, which is some function of time, and y is equal to some function of time also. Okay? So that's the general idea. Down below we have some problems to check your understanding. So pause the video right now and go ahead and try these problems. And then I will come back and go through them to make sure you got it. Okay, hopefully you've had a chance to do this. I want to make sure you understand how these work. So again, I'm giving you a couple of equations here, and we are going to plot them. So I put in the values for time, and here are my points. Sorry, they're not very clear. And I want to connect those. And again, I show the direction that this is moving. Eliminate the parameter for the parametric equation from number one. So if I've got x equals t minus 3, I want to get t by itself, and then I'm going to substitute that t value into the y equation. So I could leave it like this, which is the vertex form of a quadratic, or I could multiply out the x plus 3, and I have x squared plus 6x plus 9 plus that 1. So either equation is fine. And this is true when x is greater than negative 3. That's the first value that I have. So it is important to note the restriction on my domain. Okay, so now we've got some movement, the golf ball and how it's traveling. So here's our equation of how the golf ball travels. X is the horizontal distance, y is the vertical. And if I want to create as a parametric equation as a function of time, if I tell you that time is equal to 0.125 times x plus 2.5, I'm going to take that equation for time and rewrite it. So subtract 2.5 and divide by 0.125 to get x in terms of time. Then I'm going to also substitute my value for x into this equation. So I get my parameter of time. So wherever there was an x, I'm replacing it with the t minus 2.5 divided by 0.125. So there's the equation. And I simplified it a little bit. 1 divided by 0.125 is 8, and negative 2.5 divided by 0.125 is 20. So I just thought it was a little easier to work with like that. What are the horizontal and vertical components of the golf ball after 3 seconds? Well, time is 3, so I just substitute it into my two equations. So x is equal to 8. Oh, so I didn't rewrite it over here. Let's just quickly do that. So we have 8t minus 20 equals x. So I didn't simplify it. So there we have 8 times 3 minus 20 gives us 4. Likewise, in this equation, I'm putting in a 3 for time, and I get that the y position, how high it is 43.84 feet. And then it says, write a set of parametric equations for the line segment that starts at negative 3.8 and ends at 4.6. Well, so my x starting location is negative 3. So that's where the negative 3 comes from. Oops. Sorry, can't really see that well. There we go. The plus 7, so I'm going from negative 3 to 4. So that's a difference of 7. And I've got to assume my time is just 1 unit of time to go from here to here. So in 1 unit of time, I'm adding 7. For y, it starts at 8. So again, that's my starting value for y. And my y change is I'm going from 8 to 6, so I'm subtracting 2. So every unit of time, I subtract 2 units vertically. Okay, that's it. There's no homework for this, but we will dive more into it next class.